ready? With your Bible teacher, Carlos Carlo. What's happening in the world? Let's look at the Bible.
Good evening, everybody. Welcome to Are You Ready? I pray everybody's having a very blessed evening. We have a very special guest once again here on Are You Ready? Mike Poland. Before we introduce him, and let's have our water. Salute to all of you. We have something very important to talk about. Is happening today. We're going to talk about La Palma, and we're going to talk about Yellowstone supervolcano. So I want to thank you. If you're watching for the first time, if you never subscribed to Are You Ready, please subscribe and share this video with as many people as possible. Before we get started and asking, we got lots of questions for Mike Poland. He's with the USGS. Mike, can you please let people know, introduce yourself, who you are, what you do there at Yellowstone? Thank you for being with us.
Yeah, my pleasure. So I'm a geophysicist with the U.S. Geological Survey, and I'm also the scientist in charge of the Yellowstone Volcano Observatory. So my job is really to coordinate research and monitoring activities in the Yellowstone area, and that happens not just by the USGS, but by a number of institutions, universities, state geological surveys, other organizations. So it's a pretty neat job. I get to work with a lot of great people and study a pretty interesting place.
Yes, it's a very exciting place, and I think lots of videos have been done. We talked about before about Yellowstone, right? Even movies have been done about Yellowstone too. So once again, the information we're going to present to you, please share this with as many people as possible. We're very happy, honored to have him once again here on Are You Ready? And well, let's get started. You ready?
Yeah, fire away.
All right, here we go. We're going to start first of all. The majority of our questions, which I know a lot of people are saying, I want to hear about La Palma. La Palma. Mm-hmm. Okay, we'll get there. But first, let's go. We're going to talk about Yellowstone. Okay. How is Yellowstone doing it? And I've seen some of your videos. Can you explain to our audience here on Are You Ready? What is going on? Anything new that you've seen? I believe there was a geyser. You mentioned Porkchop Geyser.
Yeah, so that was from the video that we did back on November 1st. And we just did it in front of Porkchop Geyser, which is a really kind of a neat feature. And Porkchop is one of the geysers that exploded once in its history. There are a few geysers in Yellowstone that have done that. It happened in 1989, and there were actually a number of people in the area that witnessed it. And so it was seen. It was one of these rare sort of geyser explosions, not just a regular geyser eruption, but the geyser sort of blew itself up. That was witnessed by people. And so they were able to document the kinds of sounds and sights they heard as this thing built up to a small explosion. It threw rocks, a few feet. It wasn't a really big explosion. But occasionally that happens in areas in Yellowstone, sort of some of the geyser basins that people are in. And so if it happened when somebody was standing right next to it, that could be really, really harmful. So having the record from 1989 that we do is really nice to be able to piece together what happened at that geyser.
Okay, very good. So that explosion, was it a big explosion you're talking about? Was it a very small?
It was very small. It was a steam explosion. So the Porkchop Geyser itself is a relatively small geyser. It's only a few feet across. And it sort of got more and more active over the years. And the steam vent through which the geyser was erupting at some point got blocked. And so you can imagine it's sort of like now the balloon is blowing up, but it doesn't have an outlet. And so it popped after a few minutes of this blockage. And it threw rocks just a few feet. It threw small pebbles, tens of feet, maybe in some cases hundreds of feet, so like a little fine rain of particles. But it threw rocks, a few feet. So it wasn't a spectacular event in terms of its size, but it's one of those things that, if you're just in the wrong place at the wrong time, it could still hurt.
Yes, I'm sure it could. I'm sure it could. Okay, can you explain, because I watched your video, can you explain there were three swarms of earthquakes that occurred in October?
Yeah, so there's almost always swarms in Yellowstone. It's really common. A swarm is a sequence of earthquakes that are clustered in space and time. So a bunch of earthquakes happening in the same place in rapid succession. And swarm activity at Yellowstone, about 50% of all earthquakes in Yellowstone happen as part of swarms. It's a very swarmy place. Now, a lot of these swarms are driven by water. It's sort of a misconception to say that all these swarms are driven by magma. At some volcanoes, they are. But Yellowstone's pretty unique in that it has a tremendous amount of water moving around in the subsurface. Of course, we know this from all the geysers that are out there. Mm-hmm. And it also has a whole bunch of pre-existing faults because that whole area is just cut by faults all through the area. I mean, you've got the Teton Range to the south and mountains in Montana to the north. So faults run right through Yellowstone. And so you mix that water moving around in the subsurface with these faults, and it's sort of a recipe for lots and lots and lots of small earthquakes. So that kind of swarm activity we see in October is pretty common. These swarms can be really big at times. Back in 2017, we had a swarm that was sort of in the northwest part of the park that lasted 3 months, and it had 2,400 located earthquakes. Wow. So these swarms can be pretty significant. But that's just sort of what Yellowstone does. All that water and all those faults in the subsurface, that's a recipe for small earthquakes.
And I remember, I wanted to ask you, first of all, what's been the biggest earthquake in recent history at Yellowstone?
Well, the largest earthquake near Yellowstone was in 1959, and that was a magnitude 7.3. It was the largest earthquake in the whole Intermountain West, and that was just off to the west part of the park. So off in the Hebgen Lake area of Montana. In the park, the largest earthquake ever recorded was a magnitude 6.1, and that was in 1975. That was near the Norris Geyser Basin. The largest earthquake recently, I guess I'd say, was a magnitude 4.8, and that occurred in March of 2014. And that was the largest earthquake since that magnitude 6 back in 1975. So for the most part, the earthquakes, all these thousands of earthquakes that happen every year are magnitude 0, 1, 2, an occasional 3. Those are really common. But occasionally you get, a 4 once every year or two, and then very rarely you get 6s or maybe even a 7 just outside the park.
Right. So it's those huge earthquakes are not common at Yellowstone.
Not as much as those little ones are. Yeah, but they do happen. Maybe every once a century or so, we would expect to see one of these larger magnitude 7 kinds of events. So.
Okay. And I remember the last time, because I remember, before we get there, I wanted to ask you about, you in the video you said something happened at Steamboat Geyser. You said there were 17 eruptions?
Well, Steamboat Geyser is in the Norris Geyser Basin. It's a spectacular geyser, tallest geyser in the world. It can have eruptions that go 300 or 400 feet high. And it's typically a very quiet geyser. It doesn't have frequent eruptions, but it goes through these cycles of activity. So in the 1960s, it was really active. It erupted frequently, and then it went quiet. Maybe it had just a few eruptions. In the 1980s, it got very active again, and then it went quiet. We only had one eruption every few years. And then in 2018, it started getting active again. And so we had, I think, 32 eruptions in 2018, and then 48 of them in 2019, 48 eruptions in 2020. And it's come a little bit back. So far, we've got 19 eruptions in 2021. But it's one of these geysers that becomes more active and then less active, and then more active and less. And right now, we're in one of these more active phases. And it's just putting on a show for anyone that's nearby.
Sure. It must be really interesting to stand in front of them when that happens, right?
Yeah, it sounds like a jet engine.
Really?
It sounds like you're on an airport runway.
Really? Wow, that must be interesting. Okay. Also, I wanted to have, before we go to La Palma, and just to go with this one more time. I know you've seen movies. Remember a movie like Dante's Peak,
right?
With the Pierce Brosnan was in that one. And I've seen it a few times. But to bring about such an eruption, huge, what can you go over what has to happen? And of course, I've done videos, and I've done some myself. And what if that would cause a huge, just one more time, huge eruption there at Yellowstone?
The first thing you need is magma, and there is a large magma reservoir beneath Yellowstone, It is a body of magma that basically is about the size of the caldera, which occupies roughly a third of the entire national park. So you have that magma body, but the problem with a big eruption now is that most of that magma chamber is solid. And we know it's solid because of seismic imaging, which is a technique that looks at the speed of seismic waves as they pass through the earth. And based on that can say something about the temperature of the subsurface. It's a bit like taking an MRI of the earth. And so we know that only 5 to 15% or so of this magma body is actually molten. So we don't have the eruptible magma that's needed to support a huge explosion right now. That could happen, it could change in the future. So you'd need to have some sort of rejuvenation event. You need to have something happen that melted a bunch of that reservoir before you could have a really big explosion. And so the neat thing about that is we would see it coming. Yellowstone is really well monitored. And if there were sort of an injection of hotter magma into this cool or cooler body that started to remelt some of that plasticky stuff that's down there now, that would be accompanied by tremendous numbers of earthquakes and lots of ground deformation. We'd probably see changes in the chemistry of the springs and things like that. So it would be a really obvious event that was happening in order to rejuvenate this magma body before you could even think about having an eruption of any sort, really, of any real significant size. So right now we're not really worried about a big explosion because the eruptible magma isn't there.
Isn't there? Okay, very good. All right, well, let's begin with La Palma.
Okay.
Man, this is talk about that's what everybody's when you go on Google, that's the thing everybody's thinking about right now. Yeah. Okay. First of all, do you know when did La Palma begin to erupt recently? Do you know when it all began?
Yeah, it was in late September that this current eruption started.
Okay. Do you know what may have brought about this kind of eruption there?
Well, it's not uncommon for the Canary Islands. There have been many eruptions in the Canaries. The previous one before this was on a nearby island called El Hierro, and that occurred from 2011 to 2012. That eruption was submarine. It was actually off the coast of the island.
Okay.
But these islands are actually very similar to Hawaii in that they have this magma source beneath them, and it's a little bit less vigorous in the Canary Islands than it is in Hawaii. So we see a lot more frequent eruptions in Hawaii.
Okay.
But in the Canary Islands, the same sort of magma source is there, and every so often you'll see an eruption that sort of pressure builds, and then you get an eruption. And it happens at many of the islands, at Gran Canaria and Tenerife and El Hierro, La Palma, Lanzarote. So you can get eruptions pretty much at all these islands in the Canaries because they are so similar to Hawaii.
So La Palma is one of the islands of the Canary Islands.
Yeah,
correct?
Absolutely.
Okay. Okay. Is it? I think you answered that. It's not unusual for La Palma to have these kind of eruptions.
No, in fact, it had eruptions like this in 1971 and also in 1949. So there eruptions like this happen. Now, this is one of the larger in terms of the volume that's come out at La Palma. But of course, the history of the Canary Islands only goes back a few hundred years. So that's sort of all we have to go on for comparison.
Exactly. Okay, so you said in the next one, I think you answered also, when was the last time, before this time, when was the last big one? If you could repeat that again. Before
1971 was the last time.
1971.
Yeah, and before that was 1949.
1949. So it isn't as though this is like a regular thing. It goes to a big span of time before it does have these eruptions.
Yeah, there can be decades, in some cases centuries between eruptions. And that actually makes some of these volcanoes a bit more dangerous, not because they'll erupt any differently, but because people tend to forget that it's an active volcano. 50 years is a long time for a human. And that's an easy amount of time to forget that some of these volcanoes might be active. So volcanoes that erupt only once every few decades or centuries, it's easy for us to forget about it.
Okay. Now, one of the things I was watching, and I'm sure you've seen the videos, it spewed on November 19th. It spewed gas and ash. Now, can you explain to our audience on Are You Ready? What kind of ash are we talking about, and what kind of gases come out of a volcano? Can you explain that to everyone?
Sure. So magma, you can think of it a lot like carbonated soda. Magma has gas that's dissolved in it. And as the magma gets closer and closer to the surface, that's a bit like taking the cap off the soda. The gas will start to come out because there's less pressure on it. And so the main gases in most magmas are water, so steam essentially, carbon dioxide, and then there are some sulfur gases like sulfur dioxide. And so the closer the magma gets to the surface, the more of this gas comes out. So whenever you have an eruption, there's a lot of water vapor that comes out. There's CO2 that comes out. There's sulfur dioxide that comes out. In smaller concentrations, there's other stuff. Some of it's really nasty, like hydrochloric acid is one of the gas species that can come out. So that gas emission is kind of constant throughout the eruption, but it'll fluctuate in terms of just how much is coming out. And then the ash is generated by the eruptive activity itself. As the gas is coming out, it sort of busts up the lava flows, and you can almost think of it like it's the magma is like glass, and so it's almost like when you see glass blowers, they'll stretch out the glass and make different shapes, and that's kind of what's happening within a volcanic vent. That magma is glassy and it's just being stretched and torn apart, and that'll create little fragments that then waft out. And so that's the kind of ash that's being generated. These little fragments of glass, basically, that are light enough to waft out of the vent.
Okay. Now that ash, right, that comes out of, as I know, a human being cannot swallow this ash, correct? It's pretty deadly.
I mean, you can, but it's at some point it's not healthy. It's a bit like just about anything, like inhaling sand in a sandstorm. It's in large quantities, it's just not going to be healthy. But sort of coming into contact with it or inhaling a little bit of it is not going to kill you instantly. But it's the kind of thing you don't want to be exposed to. We have sort of rules. The gas is the same way. Some of the volcanic gases can be pretty toxic when they're in high concentrations. And so volcanologists, when we work in those kinds of areas, our rule of thumb is as soon as we start encountering those situations, we leave. Even though we have protective equipment, breathing equipment, so we leave, because with volcanoes, the best policy is always just not to put yourself in harm's way. To get out of the way of what the volcano is doing, whether it's gas, lava, ash, whatever.
Okay. So the best policy is move out.
Right.
Get out.
Yeah. The best policy is to not be there.
Don't be there. Move it out. Okay. Now, one of the things I also saw, and I was amazed, I saw a video of the lava flow, and I saw a picture of the towns in La Palma, totally covered with lava. I thought I was watching a movie, but it's real. I mean, a whole town covered by lava. Now, my question would be: how does that? I mean, how fast can lava flow? I mean, move as be able to cause that damage. And of course, they had evacuations, they already evacuated.
Yeah.
But how fast does lava flow that it can be that big, can destroy a whole town?
Well, it sort of depends on the condition for the lava speed. So if you eventually, as the lava flow kind of develops, it'll actually turn into something that looks like an above ground river. It builds up these levees, and then it has a channel, and lava in a channel can really move. That can go 25, 30 miles an hour pretty easily. Wow. We've seen that in Hawaii regularly. But the initial phases of lava flow, it's not moving near that fast. This is the kind of thing that you can walk away from. So lava flows are once they're going, once you know what the direction they're going, then you can evacuate towns, you can evacuate people. You're not going to stop them. I mean, you can divert them. There's some measures you can try to take, but ultimately, the just sheer mass of the lava flow will overcome a lot of barriers. And so this is one of these cases where it's time to walk away. When a lava flow is coming, you leave.
Get out of
By the
Dodge.
time the really fast flows have developed, then the flow has already sort of established itself.
On a question, how hot can lava go? Can lava be? What is the temperature? I mean, it's huge, very high.
Yeah. It's in the neighborhood of 2,000 degrees Fahrenheit.
Wow.
It depends on the composition. You know, it can be a little warmer, a little cooler, but it's right in that neighborhood, 2,100 degrees Fahrenheit, something around there.
Wow. You're talking about if a human being is near one of those things, they don't have a chance.
Yeah, it's in fact, the heat that comes off the flows themselves is pretty intense. You don't have to be in direct contact with it to feel just how hot it is. So yeah, there's no surviving a lava flow.
So just the heat from the lava, you don't even have to be. How far away? I'm just.
Well,
curious.
fortunately, it doesn't go that far. Okay. You can get pretty close, but as when we sample lava and so forth, we always because you want to get samples of fresh lava in order to take its chemistry and really understand more about what the gases that are dissolved in it, that sort of thing. When we would take samples of this, especially when we were working in Hawaii, we would wear special clothing that would insulate us. In fact, the clothing we wore is made out of Nomex, and this is the same clothing that race car drivers wear because it won't burst into flame, it won't melt. It's really heat resistant, so it's designed to be worn in these, as a protection against these kind of hot situations.
Wow. No, because I saw that picture and I said, "Damn, wow, that is amazing, amazing." So, like I said, it did look to me like science fiction. Dante's Peak. Now, what I have here? What the possibility? Oh, here's the big one. Okay, now, this has been talked about, and I've seen quite a few videos on what I'm asked, and I think I've asked you before. Then we mentioned it last time a little bit on La Palma, but it's still in the news. I mean, since the last time when you were on, La Palma's still there. I mean, people watching La Palma. It's like live video video of La Palma. So my question to you is, what are the possibilities? Okay, one of the things people are saying is if the island breaks off, the lava causes the part of the island of La Palma to break and to go into the. Now I'm saying this because a lot of people have been talking about this stuff. So if a piece of the La Palma, the island, breaks off the island, goes into the Atlantic, then according to what I've heard, it will cause a huge tsunami and it will head towards the east coast of the United States.
Right.
Now, my question to you, what are the possibilities or probabilities of that happening?
So the possibility or probability of a giant tsunami hitting the East Coast is zero.
It is.
And there's a bit of a story behind this, so bear with me. So this whole thing originated from a scientific paper that was published 20 years ago in 2001. There were a couple of scientists that looked at La Palma and said, if it collapsed, what would the tsunami look like, right? Because it would generate a large tsunami.
Right.
And they propagated that out to see, there would be like a 100-foot high wave that hit Florida, New York City, or something like that. Interesting idea, right? Kind of compelling. This spurred a lot of other scientists to start examining the problem. And they started finding issues with that original study. So, for example, the mathematical model that was used to create this model tsunami, it made too many assumptions. It didn't account for the bottom of the ocean and the shape of the bottom of the ocean. It also didn't account for something really fundamental about landslide-caused tsunami. They can be huge near their sources. And in fact, we know that huge waves have hit the Canary Islands. There are tsunami deposits that are over 400 feet above sea level in the Canary Islands. So we know there have been massive tsunamis in the Canary Islands. There are no big tsunami deposits on the east coast of North America or South America. And that's because landslide-induced tsunamis fall apart really quickly when they go long distances. So they're really big close to the source, but the waves sort of interfere with one another. And the farther away you get, the more they calm down. And this is different than earthquake-induced tsunami. So, of course, we're all familiar with the tragedy in 2004, the Boxing Day tsunami, where the earthquake occurred in Indonesia and people died as far away as Madagascar from the tsunami. But that's because earthquake-induced tsunami have a different form, and they can actually maintain their strength over whole oceans. Landslide-induced tsunami can't do that. They fall apart too quickly. So even though there would be a very large tsunami close to the source in the Canary Islands, it just doesn't go as far as the east coasts of North and South America. The waves sort of fall apart by the time they get there. That original 2001 study also made assumptions about the size of what would collapse. And in the 20 years since, oceanographers have looked at the seafloor around La Palma and El Hierro and Gran Canaria and Tenerife, all the Canary Islands. And they found that the size and the shape of the landslide is much, much smaller than the 2001 study assumed. And that has a lot of implications for how the collapse would happen. So it was an interesting idea in 2001, but there's no evidence for it ever having happened before in the east coast of North or South America. The physics aren't right. And then a lot of the assumptions that went into that 2001 study just weren't correct. It's not to say that it was a really bad project. It spurred a lot of interesting ideas, a lot of work later on. But it also spurred a whole bunch of, like documentaries and, you've seen this too, I'm sure. There's pictures of a giant wave that's the size of the Empire State Building, right?
Right.
That's,
I see that one.
Yeah. So that study got grabbed by the Discovery Channel, and all the people want to make really amazing documentaries to show this gigantic, wave. And then new research comes along and says, you know what, we understand this process better now, and that's not the way it works. But no documentary is ever going to go backwards, right, and say, oh no, here's the rest of the story, right? They've had their documentary, they got their show, and they moved on to something else.
Correct.
So, unfortunately, what we're left with is the popular conception, the popular understanding of this is that it's possible. But in the 20 years since that idea was proposed, we know a lot more about how this works. And that's why I can say with total confidence that the chance of, a La Palma collapse hitting New York is zero. Now, that's not, and frankly, the whole idea of a collapse itself it's very rare. It happens every few 100,000 years in La Palma,
really?
Or in the Canary Islands in general. So, they had an eruption in 1949. Why didn't it collapse then? It had an eruption in 1971. Why didn't it collapse then? Why is this the eruption? And frankly, the reason everyone's worried about this being the eruption is because the idea was proposed in 2001 and put into some documentaries. And, social media is a thing.
Right, exactly. So everybody's saying, something cataclysmic was coming. Right. And I think that's why people are watching it and say, oh, did you see? It fell.
Right. They're waiting for this thing to happen, which, the odds of it happening anyway are minuscule. And there's no evidence for it as well. We would look at how the island deforms, how the island is moving. If there were going to be a landslide, you'd start to see the island start to break loose, that chunk break loose. It's not happening. You can actually go and see all of the GPS data, the ground deformation data for the island on the website of the IGN. That's the agency that monitors La Palma. So you can see for yourself that the island is perfectly stable. But even if it did, even if the worst happened, sure, there would be some devastation in the Canary Islands, but that wave would not reach the U.S. with that kind of strength. It just falls apart too quickly because those landslide-induced tsunami, they're huge near where they happen, but then they fall off very quickly.
Okay, so just to make sure for me to understand, the tsunami that they're talking about caused by a landslide, right, from the island, cannot, as the information you're sharing, cannot really produce that kind of huge tidal wave hitting the East Coast. But if there was an earthquake somewhere in the Atlantic,
Exactly.
then that could, like, let's say there was an 8.8 or 9
Yeah,
earthquake in the Atlantic, that could cause a tidal wave to the
it
east,
could.
not the landslide.
It could. And in fact, there have been tsunami in the Atlantic that have hit the East Coast in historic times. Like there was one in 1929. It didn't cause a lot of damage, but it occurred. I believe it was associated with an earthquake off the Grand Banks in the sort of the North Atlantic area. And there are places that can generate very strong earthquakes in the Atlantic, especially in sort of the Caribbean area, because the earthquake situation there is such that you could have a large earthquake. And in fact, there are tsunami deposits in the Bahamas that are high, that are, you know, tens of feet above sea level. So those may have been generated by earthquakes. We don't know for sure. But earthquakes, yeah, that's how you can make a tsunami that goes a very long distance and still maintains its strength.
Wow. Well, I hope we kind of ended that kind of story there. The idea of a landslide leading to a huge tsunami. Well, somebody out there saying, I don't believe what he just said. Forget it. I heard it's coming. I'm going to keep an eye on that island, and something's going to happen. I'm waiting for it to split so I can get in my car and leave my house. So
and unfortunately we've gotten questions from people that have said just that. Like, should I leave the area that I live in? You know, I live in Florida. Should I leave? Like, well, no. We know that this is, but I understand that it's very hard to accept that, right? Because you go on to social media, that's all you see, right? La Palma's going to collapse, and you go to the Discovery Channel. Guess what? They have a documentary that shows this. But this is sort of the problem with the way we do information, is that first idea, that really spectacular, horrible idea, gets a lot of attention. And then you get the follow-up information where we've, you know, explored the idea more fully. That doesn't get the attention.
And nobody wants to pay attention.
It leads to a lot of misunderstandings that, you know, that could be fixed.
And just one thing leads to another. Somebody spreads the story and becomes really big. Right. Okay. Well, first of all, before we finish tonight, and once again, thank you for being on our program. And Are You Ready? Well, thank you. We're very blessed to have you. What would you like, of all that we have spoken tonight, is there something you want our audience on Are You Ready to remember? What do you want to, what one thing you would like them to keep in mind of what's happening when it comes to volcanoes?
When it comes to volcanoes, well, I think a neat idea about volcanoes, and this is somewhat unique among all of the hazards, is that volcanoes tend to give warnings before they erupt. So earthquakes, there's not a whole lot of warning. You know, we kind of know the rough recurrence intervals of when an earthquake will happen, but an earthquake will happen without any sort of buildup in activity quite often.
Correct.
Wildfires, right? We kind of know the conditions for a wildfire: really dry summer, hot weather, lightning maybe. But there's not like a week of warning that a wildfire is going to happen in a certain area. Hurricanes, you get maybe a week of warning before a hurricane hits, right? So maybe you get a little bit of warning with some of these floods. Floods, you may get, you know, a few days of warning knowing there's a lot of rain coming. Volcanoes, though, can give you lots of warning. In certain cases, they can give you months to years of warning. And so the key about volcanology is to learn to recognize those signs.
Right.
And so with volcanoes, over all the other hazards, volcanoes have an advantage because they give us warning. And I think we lost Carlos. Well, hopefully he'll make it back. But the idea is that volcanoes really do give warnings, and it might be enhanced seismicity. The ground may rise, or as magma accumulates like a balloon, growing beneath the surface. There can be changes in the gas emissions. We may see different styles of gas come out of the ground. There can even be changes in heat emissions. You might see higher temperatures at the surface as magma begins to rise. So there are all of these different monitoring tools we have for identifying how a volcano may behave in the future. And that's really key. So volcanoes give warning signs. The key is we need to be listening, watching for those warning signs. And when we see them, we need to be able to recognize them and then correctly interpret what's going to happen in the future. So, well, I think we might have lost Carlos, but well, thanks everybody. And if you have any questions, you can always feel free to write us about Yellowstone materials. We have an email address. It's yvowebteam@usgs.gov. YVOWebteam is all one word at usgs.gov. Always love talking volcanoes. So take care, everyone. Stay safe and stay healthy.